Welcome to Wales Tech Week 2021. Thank you to our partners. Enjoy the session.
Good afternoon and welcome to our Wales Tech Week showcase. Today I'll be introducing what the Centre for Photonics expertise is, what it does, and then handing over to Martin Lee, Technology Director at Grafmarine, to tell us about how Grafmarine are making waves in the renewable marine energy sector. Mike Walker is with us too. He'll be looking at the Q&A. So if you do have any questions, please put them in the chat and he will log them. And we've made some time at the end of this presentation to answer those questions. So moving on, the Centre for Photonics Expertise, or CPE as we call it, is a programme funded by European Regional Development Funding and Welsh Government to support industry academic collaborations. So the ultimate aim of our project is to boost business growth in Wales by supporting new product and new process developments. So the CPE consists of 4 university partners: the University of Bangor, Aberystwyth, the University of South Wales, and the lead, Wrexham Glyndŵr. And we have an office based at the Optics Centre, you can see in the picture here on the left-hand side. And our work and our team is dedicated to provide solutions for companies who have business challenges. And we use our photonics expertise to do this. So to give you some examples, it could be in production, in quality control, or perhaps designing a new product or process. So we tackle our challenges based on our expert knowledge of photonics, together with a company's knowledge of their system and their business sector. So we form a true collaboration. So to give you a couple of ideas here of our outputs, CPE began in 2019, and since that time we've worked with 60 separate projects with 42 different companies. And we focus on building collaborative relationships, as I've said, and we're hoping these lead to longer term collaborations, and we help with grant applications at the end of a CPE project. And so far this year we've supported almost £2 million in additional grants. So every CPA project requires a matching kind contribution, and we put a staff cost to this. And the average value of staff costs on a project is about £5,000 to £6,000. So that means that our current in-kind total investment is £340,000. And another major investment for CPE was the thin film coating plant, which you can see, and that's located at the Optics Centre. So photonics is really all around us in our everyday lives. It's light-based technology, and that involves the generation, detection and manipulation of light. So you can see the generation is something simple like light bulbs. We've got screens, detection, cameras, sensors, solar cells, and manipulation, phone, internet signals, fibre optic. And what is interesting is that according to the Photonics Leadership Group, companies manufacturing and delivering services based on photonics technology in the UK produce about £13.5 billion in output every year, and that is equivalent in size to the UK pharmaceutical, fintech or space industries. So that is really phenomenal, and it's growing. So as I said, our focus isn't just in the photonics industry. It's true, we do support photonics companies, but we work using photonics to solve business challenges. And you can see some icons here, just a few of the companies that we're working with at the moment based across Wales. And you can see they're in a variety of sectors such as scientific, medical, lighting, agricultural and packaging. It's quite endless. So our university partners all have specific specialities, and they're funded to work with us. So you're not waiting for a slice of their time, they're waiting to work with you. And each of our partners has their own area of photonics. So there's just a few examples you can see here on screen. For example, our Bangor team are experts in laser processing, and you can see that involves maybe laser texturing, engraving, welding, cutting. And the example here is where they've worked with Diamond Centre Wales on micro engraving diamonds for traceability and security. Another example here is South Wales, specialising in optical design and prototyping. There's many examples. I won't talk through all of them now, but you can see very, very interesting and exciting projects here. You can see the Shawchill one that worked on refrigeration, where the project used thermal imaging to monitor fridges and identify where performance needed to be improved. And also Mon Naturals, they needed to get medical approval for a product, which is a healing balm based on a 200-year-old family recipe. And the project provided an analysis of the exact chemical composition. And last but not least, you can see the optical coating facility that's run by Wrexham Glasgow University. And they produce some simple coatings, such as the kind you find on your glasses, or something much more specialised for applications in defence and security. And this is just a quick slide to show you the coating plant. You can see the spectrophotometer, where we do the measuring, the vacuum coating plant, and the environmental chamber. And again, if you want to know about this, do please get in touch with us. So a word about eligibility. So to qualify, a business must have an address in West Wales and the Valleys. And you can see that shown here in the pink, dark pink region. We work with all companies. You can be a single entrepreneur, an SME, or a large business. But projects must aim to have impact, business growth and development within the Wales region. And just a quick word about displacement. We don't do anything that you could buy anywhere else from another company. We don't displace anyone with the projects that we undertake. I'm going to hand over in a few minutes to my colleague Martin Lee, but just before I get to that, I wanted to talk about the type of companies we work with. So the majority of companies are manufacturers, and others include services like test and measurement or consultancy. Around 25% of the companies are photonics companies, but interestingly, the rest are split between scientific, medical, environmental, perhaps packaging, agriculture, and last but not least here, marine. And this is where I do hand over to Martin Lee from Grafmarine. Martin's technology director, and he's going to tell us about how they're making real waves in the renewable marine energy sector. And hopefully he might mention a little bit about how CPE have helped them do that. It's over to you, Martin.
Thank you, Carol. Hello, everybody. Good afternoon. My name is Martin Lee. I'm the founder of Grafmarine Limited. Next slide, please. Very simply, our oceans are 70% of the Earth's surface. The majority of life on Earth is aquatic. Less than 5% of all the oceans have been explored, and our place within that is 0.01% of the Earth's surface is actually the UK. So we're a big planet, and a lot of that is sea at the end of the day. Next slide, please. So back in 2015, when we started Grafmarine, I actually asked an Innovate UK employee, why is there no specific funding for reducing marine pollution? And I was told at the time that for most people, out of sight is out of mind. The marine industry was very much out there. It wasn't seen by people. People weren't breathing in the diesel fumes and taking in the pollution that normal transport actually imposes on people. And I was quite told very specifically to go and design something for aerospace or automotive because it has a better story for investment. And I think that's quite telling, really, because things have moved on so much since that time. And the focus now has gone back onto the oceans and very much the green technologies that support the way forward with that. The other fact I put on here is Ellen MacArthur. You may know her as the round the world lady who sailed around the world on her own. She set up the Ellen MacArthur Foundation, and one of the really strong facts that I've come across is that by weight alone, there'll be more plastic in the seas and the oceans than fish by 2050, which is quite a startling statistic at the end of the day. And I think the focus has very much now turned back onto the ecology and looking after the environment at sea as much as on the land. Next slide, please. So how does that affect shipping and climate change? The shipping industry has been largely out of sight, as I've already said, really. By 2012, the shipping industry as a whole emitted about 3.1% of annual global CO2. If it's left unchecked, it's increasing shipping by 5% cumulatively each year. That will rise out of line with what's going on outside of that by up to 12% by 2050. So there is an urgency to actually get things done within that particular sector. Next slide, please. Just to put that into perspective, we look at the cruise market in particular. Cruise ships are very heavily specified. They have overcapacity with their engines because of the number of people on board. They are huge, huge polluters. Just to put that into perspective, this is a picture of the Harmony owned by the Royal Caribbean. She's got two 16-cylinder Wärtsilä engines, which will burn 66,000 gallons of fuel each a day, which is a huge amount of energy being used. Some of these ships can have up to 6,000 or 7,000 people on them, and you can imagine the amount of energy and power that's required, not just to move it, but also to look after the people on board. Next slide, please. The other side of that is the cargo side. So in the world today, nobody really knows how many containers there are. That wildly estimates between 100 million and 170 million shipping containers. Every year, we will need 300,000 new shipping containers. So you can imagine the number's just going to go up and up and up. And with that comes the ships that deliver it. So roughly 90% of the world's goods are transported by the sea, with over 70% which are containerized. And that's not going to change. Air travel is obviously very polluting, and the sea is always an easier way to move things around at cost that is more palatable to what people will pay. Just to put that into perspective, one of the big carriers, Maersk, have a fleet of 750 ships. And they did a research project, and they worked out they are 0.1% of all global carbon emissions, which is huge. And they really are looking for a solution to this. And that's driven by shareholders, as well as people not wanting to be seen as polluters in the world today. Next slide, please. So in 2015, the IMO, the International Maritime Organization, finally realized that there was a crisis coming in terms of pollution. The heavy fuel used in marine contains a lot of sulfur, and what they imposed on the industry as a whole would be to reduce the percentage of that sulfur within the fuels from an existing 3.5% to 0.5%, which would be effective from the 1st of January 2020. That did come in, and to be truthful, it was largely ignored initially. The shipping companies were keen to pay the fines because they weren't really imposing too much financial damage onto them. So there was then a decision to carry that forward, and that's where we are going forward now. Next slide, please. So in 2008, we had the Great Recession, this also threw up something quite interesting, really. The number of goods that were being shipped around the world reduced for obvious reasons, and a way that the shipping companies could actually save money was to what they call slow steam. Slow steaming is basically reducing the average speed that you travel at. It reduces the amount of fuel used, but it also lengthens the journeys, and it causes huge wear and tear on components within the engines. So if you imagine as a car driving along the motorway at 20 miles an hour, yes, you would save fuel, but the amount of carbon that would build up in your diesel engine will be quite damaging at the end of the day. But that was a good indicator for ourselves, because it actually highlighted that you could save around 10% of fuel. So we use that as a benchmark very early on as a possible guide as to where we wanted to aim to go. Next slide, please. So now the focus is on zero emissions by 2050. Initially, there were two main candidates to achieve that. One was LNG, which is natural gas, and biofuels, which are natural fuels grown as food is in fields. As we've progressed, it's become clear that these two kinds of fuels are not what was originally going to be the solution to the zero emissions project. LNG emits as much as 82% more greenhouse gas over a short journey compared to marine fuel oil. Biofuels are extremely expensive and difficult to bunker. And they also have now different requirements as well. So other transport are looking to use biofuels, buses, trains, trucks. And by that, what that basically means is that by 2030, only 7% of the demand can be fulfilled by biofuels. So there needs to be another solution. Next slide, please. So the only new energy creation options for marine are what's available now are the following four, really. Shoreside power. So you'd look at onboard battery banks, which can be very space disruptive on retrofit ships. Large areas of ships would lose working areas of their ships, container space, but that would be replaced by battery banks, which take up a lot of space, add weight, and cause all sorts of other problems as well with electronics. Wind is another option. So there are Flettner motors which are attached to the top of ships. They look like spinning cylinders. They're very noisy. They also require a certain amount of changes to the ship structure. And bizarrely, they have to be turned off when the wind gets too strong. The other option is solar. So up until now, solar's had a limited durability. It's been very specialized. It's been largely inefficient. And as an actual energy creation system, it's not been scalable. Hydrogen is something on the radar, which is being looked at by quite a number of companies in the future. This can be actually stored molecularly in ammonia. But again, it doesn't answer all the questions. There are difficulties in storage. There are difficulties in the range that you can store of hydrogen. So, for example, diesel takes up a lot less space than hydrogen for the same route going forward. Next slide, please. So the tighter regulations that are coming in through the IMO, leading on from 2015 regulations with the lower sulfur. By 2026, the revision of existing and setting of future design standards should be based on the performance of the 10% best ships in the market. And this puts huge pressure on the shipping market as a whole. Ship's life cycle is about 20 years, and it's not something that you can turn on and off overnight. As you can imagine, there are things that need to be planned in. It takes 4 years to come up with the idea of a ship and then actually go towards finishing it and manufacturing it. So these timetables need to be planned in advance, and the hesitancy in the market and the need to comply with this legislation is causing quite a lot of discomfort at the moment. Next slide, please. So these actual regulations, what do they actually mean for the ship owner? Very simply, and these are extensive regulations, I'll just summarize them here. Phase one is an overall 10% improvement target within the energy efficiency of the vessel for ships built between 2015 and 19. Phase two is a 15 to 20% increase in efficiency for ships built between 2020 and 24. And after 2025, they need to be 30% more efficient. There's also tighter regulations in the wings that will come through that mean that after 2025, it will be very difficult to build a fossil fuel ship as a new project. Next slide, please. So this is our solution. This is Grafmarine's Nano deck. What we've got here is a self-contained tile. It has PV on the top and has energy storages inside the tile. It can be used across any flat surface to create and store energy that can be used on tap when required. Next slide, please. So going back to my original comment on the previous slide, our objective really was to try and save up to 10% of energy on a ship. We asked the IMO to digitally test our tile based on prototype data, and that's exactly what it achieved. We actually saved up to 10% hypothetically of propulsion energy using our tile structure overlaid onto a retrofit oil tanker. And we've got quite a stringent design process going forward, quite ambitious in technology terms. We want to increase that 10% up to about 40% in 5 years' time, in line with the legislations that's coming through. And where we're different is that we can actually update the tiles on a ship. So the tiles we fit tomorrow at 10% can easily be replaced by tiles that are up to 40% potentially in 5 years' time. This doesn't have to be dry docked. It can be done at sea, and tiles can be replaced and updated as and when they're required to. Next slide, please. We've also noticed there's many, many options. So we're looking at not just the marine sector, we're looking at wind turbines, we're looking at tidal, we're looking at inland structures, ports, vehicles, and buildings. What we can provide is a seamless array of energy that can be used for a very wide variety of projects. So anything that requires its own power source, anything in a harsh environment, we can provide different energy into that structure depending on what the requirement is. So we're looking ahead into many different options, many different projects that we can use our technology going forward to work with those different scenarios. Next slide, please. So CPE, yeah, big thank you to CPE. We worked with CPE pre-lockdown. We scoped out a project with the University of Bangor, and they did really well. We had lockdown, we've had COVID, as we all know, and we've maintained contacts. They've kept things moving through this difficult time, and they delivered what they said they were going to do, which is great. And we're now moving into the second phase of that, which is a slightly larger project, and hopefully we'll have the same successful outcome. Thank you. Next slide. So part of our individuality with our company, through research, we've looked at the actual ocean plastics issue, and around about 50% of ocean plastics that are polluting the oceans at the moment are actually discarded fishing nets. A lot of that is in the Far East. It's an ongoing problem. These things do not disappear. They last for many, many decades. And when they do get broken up, they become microplastics, which end up in fish and back into the food chain. So looking at what we could do to try and offset some of that, what we're trying to do is, through chemistry, we're actually going to reintroduce some of the fibers from these fishing nets that are recycled into our composites and become part of the product. So we have a generational set of materials that can be recycled and reuse the plastics that are in the ocean, as well as reuse the materials that we create. We are very aware that we don't want to be the ocean polluters of the future by literally replacing marine fuel with another problem in 20 or 30 years' time with PV and battery technology, which is redundant. So we're very focused on the renewable energy side. We're working with battery companies which are fully recyclable, and we're creating our own technologies which are very much focused on second life and repurposing. So if we take an array off a ship, we've got a plan to use that in on our land-based projects and in different scenarios on land in poorer countries where the capital cost will be reduced, but the energy requirement is still the same. Next slide, please. So as I mentioned, really, we're focusing very much on the environmental side. We're looking at expanding the technologies within NanoDeck. So we're looking at wind technology, hydrogen technology, and we're also developing world-leading energy storage materials. We're now part of a Tier 2 partnership with Manchester Grafmarine, looking at advanced materials, advanced energy storage materials, which will take us into the future towards that higher percentage of propulsion that we're going to achieve. But we're still going to continue to work with R&D in Wales, hopefully with CPE and the universities in South Wales, which are very strong, certainly with PV and other technologies. And it is our intention to manufacture in Wales as we approach commercialisation from 2022. Next slide, please. And that's it. Thank you.
Thank you, Martin, for that. Absolutely amazing. Yeah, you know, I didn't personally know a great deal about the issues of the sea when this project began, but it's a fantastic product, Martin. So it's been a great insight into the renewable marine energy sector. So I'm going to turn now to Mike and ask if there's been any questions for us on the chat. I've put up our slide here that's got my contact details in and my colleague Hazel Hund's contact details. So again, if you need to know more about CPE, do get in touch with us, or if you have any questions for us, we can take them now. Mike, over to you.
Thank you, Carol. Thank you, Martin, for a very fascinating presentation there. I'm sure we'll all agree. Yeah, so we've received a few questions so far. We'll just work our way through these. First one is for Martin. So it's been asked, have you faced any challenges in getting the NanoDeck prototypes manufactured?
That's quite an open question, really. Yeah, I think if you're developing any new technology, it poses its own issues, shall we say. So we're looking at potentially working with a manufacturer in Wales to actually bring all that together.
That's great, thank you, Martin. And sticking with the theme of the NanoDeck technology, we've had another question. Approximately what percentage of overall power would NanoDeck be expected to provide to a normal size ship?
So at the moment, what we're doing is we're producing a number of modular prototypes, which we're testing with quite a few different scenarios. So as you can imagine, we've had one on test over the winter in Wales. It's not been particularly sunny, but we've managed to get a trickle charge into the battery, which has been really good. Our PV is very different from the standard material that's on people's roofs that they associate with. So it works in a different way. We expect that as we go more towards warmer climates, obviously the efficiency of the PV will improve. But the other area to this as well is the electronics and the storage materials that we're developing. So it's not just about the PV. It's about actually retrofitting batteries in a way that is not disruptive to an existing ship. So there's a combination of things there, really. In terms of the question to the answer, sorry, the answer to the question even, we did a scenario test, as I mentioned, which produced about 10% of the energy, hypothetically, into the ship's energy use. If you put that into marine fuel, the ship that we overlaid it onto, these tankers are big. They use about 100 tons of fuel every day. So a 10% saving is 10 tons of fuel a day. If you look at that from an environmental perspective, every litre of marine fuel is using about 3 tons of carbon to create that. So that's quite a hefty amount of carbon that could be saved using these technologies.
Sounds interesting. Thanks, Martin. Okay, so another question here. I know we touched upon it throughout the presentation, but I'm wondering whether we could perhaps expand on this a little more for the viewers. Has it been difficult to maintain general momentum through recent lockdowns and general COVID-related restrictions?
Yes and no. I think I'd probably echo many companies that have been through this. Really, I think on the positive side, COVID has made people more accessible. There's no longer the excuses they're not in or they're in the car. Everyone's been at home. If you had the contact details, you can get hold of people, which has been great. The downside of that is obviously, universities, a lot of industries not been able to go into the kind of making and doing scenarios that were previously available. So in addition to that, we have a lot of challenges with companies switching to making equipment for the NHS over that period as well. So yes, there have been issues with trying to get, certainly, at certain times, trying to get prototypes made. We have experienced some difficulty in supply, yeah.
Okay, thank you for that. So next question, Hazel's written on the chat here. Great product. Are you going to be using proprietary technology, and when do you see field testing taking place?
So what we're doing at the moment, we're working with a couple of catapult centres. From a manufacturing perspective, we're making our quite a high number of prototypes into modular systems so that we can test in as many different places as we can, and that's all about data. What we're going to do then is we'll bring all that data together, we'll make improvements, we'll work towards a final pre-manufacturable version, hopefully early next year, and then we'll go into production at some point in 2022.
Excellent, sounds very exciting. Yeah, just to say at this point, please do keep the questions coming in. I can see we've had a few so far, so if anybody has any burning questions to ask Martin, now's the time to do it, definitely. So the next question coming up sort of asks about how you got involved with CPE, really. So how did you first sign up for CPE collaboration, and how quickly was this turned around into a working project? I.e., was there a long paperwork process involved, for instance?
Gosh, that's a good question. It was very quick, actually. I was pleasantly surprised. Normally, with the usual funding bodies, there's a paper trail. There's always a paper trail. I understand the reasons for that, obviously, but to actually start the actual project kickoff was very, very quick. I was pleasantly surprised. And it's not been overburdening, the actual paperwork. The process has been very, very straightforward, and that's down to the team, I think, keeping things moving. As I mentioned, even during lockdown, they did a really good job. So, yeah, well done, yeah.
Brilliant, thank you, Martin. Yeah, well, we've still got time for questions, so there's no further questions at the moment. But please, if anybody does have any that they wish to ask, now's the time to do it. So we'll give you a few seconds just to see if we get any more coming through.
And just to mention in the meantime that we do have a virtual booth open. So if anybody would like to come and chat to CPE, do try the exhibition booth experience and come and have a word. If we're not there, we'll have our video running and you can leave us a message.
Thank you, Carol. Yeah, we're still just waiting to see if we get any more questions while we've got the time to do so.
Well, I think, Mike, if anybody has got any more questions and they want to come and talk to us in the booth, we can put them in touch with Martin from Grafmarine. So I'll close our slide down there, but I hope you've had a chance to make a note of those emails and numbers. I'll stop showing there. Yeah, thank you very, very much for coming along to our showcase today. We were very proud to present Grafmarine, one of our CPE projects. And if you do need to get in touch with any of us, do contact Hazel and myself.
Yeah, thank you for the opportunity to talk as well. That's great. Thank you.
Thank you very much.
Thank you, everybody.
Thank you for watching. Rewatch all of our sessions online. Thank you to our partners.